then system interface, that is a BFM, and peripheral, that is RTL code. So the processor is replaced by ISS that interface with the source level debugger and provide an interface to the peripheral through processor BFM. So they are talking about this. Instead of processor, they are using interrupt service routines, and on one side it will talk to this source level debugger, and on the other side it will create a mechanism to talk to peripherals, RTL. Here your bus function model is there. So the peripherals are modeled in RTL code in Verilog or VSTL. So this is RTL code. Peripheral is your RTL code. It may be a UART or interrupt controller. Now to eliminate design error before the silicon is fabricated. So what is this statement means? They are talking about the objective of co-verification. Before fabrication, you need to find all the bugs in your DUT. So that is why you are performing co-verification, to enable engineer to design, develop and debug both hardware and software simultaneously. So this is only the point where your hardware will interact with the software, real software. Before that we have to use software bus function model in order to configure the peripherals. But when your real device drivers are ready, then you have to interact your real device drivers with your RTL code. To achieve fast turnaround time in the design cycle. Fast turnaround time means you want to time to market is an important concept, right? So that is what they are trying to say. Turnaround time in the design cycle should be fast. With the help of core verification, you can achieve that thing much more faster. So how core verification will help in verifying or debugging? Okay. So first statement they are telling that display the software source code and processor state. So there are some display are available by which you can see the source code and processor, in which state the processor is. Then second point, they are telling that configure the processor memory and input output address map, enabling accessibility to the hardware component. Now they are telling that you have to configure the processor model or input output address map. Okay. So that why they are telling that these things, so that you can access the hardware components like this. You can access any of the RTL. Synchronize software and hardware clocks. So you cannot directly interact between software and hardware. You have to synchronize this hardware clock with the software clock. Detect the interrupt generated by the peripheral using ISS model. Now suppose this RTL code, it is generating an interrupt to the processor. So during that time you don't have processor, right? Instead of that you are using ISS. So it will generate a interrupt to the ISS. ISS can perform read or write on the memory instantiated in the hardware. So this ISS, suppose take example, this is UART. Okay, after receiving the data, your data is here in the register. Okay, so this UART will enable an interrupt to the processor. Processor will read the interrupt and processor will come to know, yeah, this interrupt is coming from UART. Processor will come and fetch the data from this and keep it in a system memory. So that is what they are trying to say in the hardware. Here one memory is there, like one register is there. You read the data from that register. Facility to set breakpoints or single stepping in both software and hardware description language for detailed analysis and debug. So we know that this is the thumb rule in debugging, like you have to set some breakpoints, even not even in hardware but in software also. Coming to co-verification environment, how to create a co-verification environment. Okay. So we know that in co-verification we have to interact hardware and software. So there are two environments. One is software environment, one is hardware environment. Okay. So processor model will take care of hardware. So you can say the processor or memory model will act as a bridge between software environment and hardware environment. So you see. So the software environment consists of a graphical user interface and software development tools such as compilers, linkers and debuggers. So this is a GUI interface. Like in model sim you have seen hardware graphic user interface. Similarly in software environment they will create a GUI interface with the help of TCL or TK like scripting commands. Okay. After that software tools are there that will compile, link and debug. So if it is Linux, then